Hello students, today we are going to introduce you speed of transverse wave on stretched string. Means when a wave is produced in a string, what will be the speed of on a stretched string. Here we have to remind one thing, that speed of transverse wave depends. First one is linear mass, linear mass density, and the second one is tension in that string. We are taking here the expression for linear mass density of a string as, and the tension in string as capital T. Also we know kinetic energy of a particle is concerned with mass, and propagation of disturbance is due to the tension in string. Now if we think about the dimensions of tension in string and the linear density of that string, we know that dimension of tension in a string is equals to capital M power 1, capital L power 1, capital T power minus 2. Similarly, dimension of linear mass density of a string will be given here by capital M power 1, capital L power minus 1, and capital T power 0. Now for these expression, if we consider the dimension of tension, the equation 1, and the dimension of linear mass density, the equation 2, on dividing the expression 1 by the expression 2, we get the dimension as follows: ml t minus 2 divided by ml minus 1, which will be equals to L2 t minus 2, and we are considering it the expression 3. Now see here, the velocity of transverse wave in a string depends on the linear mass density of a string and the tension in that string. So we get the expression for velocity of wave in a string as using expression 3 as V equals to square root of tension divided by linear mass density of the string, because here dimension of velocity dimension of velocity t minus 1, t to the power minus 1. So we have got the expression for the velocity of the transverse wave in that string, and denoting is as equation number 4. And our conclusion is here that speed the speed of transverse wave does not depend on the frequency of wave. Now we can take here a numerical example for this expression of velocity. Say a steel wire has 0.72 meter length, 5 multiplied 10 to the power minus 3 kilogram. If the wire is under tension of 60 Newton, what will be the speed of transverse wave on the wire? For this, the solution we can provide here. As we know here, the length of the wire, say the length of the wire equals to 0.72 meter. The mass of the wire is 5 multiplied 10 to the power minus 3 kilogram. So linear mass density mu will be given by here 5 multiplied 10 to the power minus 3 divided by 0.72. That will be equals to multiply 10 to the power minus 3. Now since we have here the tension in string equals to 60 Newton. So the velocity of wave in wire is square root of tension divided by the linear mass density, which is equals to square root of divided by 6.9 multiplied 10 to the power minus 3, and we get the result here. The velocity equals to 93 meter per second. So that is our answer which was required by us. Thank you all of you. That's all for this lecture. We will continue next.